friends, in this video we will study about the 8253 or 8254 programmable interval timer, its block diagram and pin description. So let's start with our topic. The programmable interval timer, its IC number is 8253 or 8254. It's an especially designed timer which is used for the microprocessor for the counting and the timing operations. So we can say that it's an especially designed chip for the microprocessors to perform the timing and counting operations. And these timing and counting operations, they are implemented through software. That means we are writing the software instructions, we are programming the chip, and then that chip is performing the timing and the counting operations. That is why the name of this IC is programmable, because it can be programmed. We have the software for it. And interval timer, because it is providing the time intervals, or it is providing the time delays at some specific time intervals. Okay, so we can have here that these timing and counting, it is provided by the, or it is implemented through the software. So now comes that what is the need of this programmable interval timer? Why the microprocessor needs the use of this chip? So let's take an example that if the microprocessor, suppose it's performing n task. So microprocessor, it is performing n task, and it wants that after the completion of one task, it takes some time delay. Okay, suppose for t seconds it wants the time delay between two tasks. So if we have like first task we have I, then the microprocessor is going to take a time delay of t seconds, and then it will perform the second task, suppose j. Now this time delay of t seconds, if we want in through the microprocessor, then the software solution of this time delay is that we will have some timer here, and we will write a delay subroutine. Time delay subroutine is there, and this delay subroutine, it is providing the time delay of t seconds. Now to get the time delay of t seconds, we have to initialize a register or register pair by some count. So for this time delay, we will need to initialize a register or register pair by a count which is equivalent to the time delay of t seconds. Okay, now each time the microprocessor, it performs the task, because it has to perform n task, and after I task, first task it has completed, then it will call that subroutine. It will initialize the register and register pair by the count, then it will decrement the count until it becomes 0, and when the count is 0, then it is going to perform the j task, and then j task will be completed. After the completion of j task, it will again have a delay of t seconds. So again it is going to call the subroutine. It will initialize the register or the register pair with the count. It will decrement the count until it becomes 0. So this has become a complex task. Okay, every time the microprocessor it has to call the subroutine, and because every time it wants the time delay of t seconds, so in between the uh, task I and j, the microprocessor cannot perform any other task because it has to concentrate on the execution of the subroutine so that it can get a perfect time delay of t seconds. So if we see that when the microprocessor is performing a lot of tasks and every time it needs to have a break or it requires a time delay, then this complete procedure is becoming very complex and the microprocessor is busy in it. It cannot perform any other task in between. So to relieve the microprocessor from all these complexity, we can use an external timer. And what this external timer it is going to do, that external timer will, every time the microprocessor it completes the task, that timer it will work. It will initialize the counter and it will decrement the counter, and it is going to provide the time delay of t seconds. So the microprocessor it is not busy in executing the subroutine. It is free from its job. It can perform any other job, and that task of providing the time delay of t seconds will be done by the external timer. So that is the need of an external timer, and that is why the 8253 or 8254 programmable interval timer is developed for use by the microprocessors to perform the timing and the counting operations. So that is the need of an external timer, or we can say that the programmable interval timer 8253 and 8254. These are 8253 it is the lower version, and 8254 it is the higher version of the programmable interval timer. So now we will start with the features of 8253 or 8254. So now let's come to the features of 8253 and 8254. So as the programmable interval timer 8253 or 8254, it is performing the timing and the counting operations, so it will need some timers. So this IC it consists of three identical 16-bit counters, TM0, TM1 and TM2. So these counters they can be initialized by a 16-bit count, and then these counters are going to perform the counting operations. Now so it has three identical 16-bit counters, TM0, TM1 and TM2. Now these counters, these are basically the down counters, means they are initialized with the highest value of the count, and then the count will be decrement at each transition from high to low of the clock input. So these three identical 16-bit counters, these are the down counters. And they will count at each high to low transition of clock input. Suppose we have a clock here, clock pulse is there, so every high, this is high and this is low, so every high to low transition it is going to count the counters. Okay, it is going to decrement. Suppose we have started with 100, so from high to low if it is going, then it will decrement the counter by 1, it will become 99. Then again from high to low it is going to decrement the count, it will become 98. So in this way the counter will work till it's become 0. So this down counters means it is decrementing the count at each high to low transition of the clock input. Now as it is having the three counters, so these three counters, they can be operated in any of the 6 modes of 8253. The 8253 and 8254 ICs, this timer, it is having 6 modes, 6 operational modes are there, and these timers, the three timers, they can be operated in any of the 6 modes independent of the operation. Like if it is TM naught, it is working in mode 1, it will be independent from the other two timers which are working in some different modes. Okay, so the functioning of each of the timer, it is independent of each other. So we can say that we can change the modes of operation of all the three timers, or we can say that the timers are software programmable. We can write the software instructions for it. We are going to write the control word for each of the modes, and those control words, they are going to decide that which timer is working in which mode. So we can say that the timers are software programmable. We can change the operation of each of the timers. So this was about the three timers of the 8253 IC. Now then comes the maximum clock input. The maximum clock input to the 8253, it is 2.6 megahertz. So we can say that the timers can work up till the frequency of 2.6 megahertz, or we can say that it is the maximum operating frequency of 8253 timers. Now next we have the feature that as this 8253 timers, they are worked in association with the microprocessor. So every microprocessor will be different. We can have 8-bit, 16-bit and 32 microprocessors. We can have different types of microprocessor. So this 8253 and 8254, they have the feature that they are compatible with almost all types of microprocessor. Now as the programmable interval timer, we have the two ICs 8253 and also the 8254. 8254 is the updated version or the higher version of 8253. So we have written here that the maximum clock input to the 8253, it is 2.6 megahertz. So in the higher version, this operating frequency has been increased till 10 megahertz. So this is the feature of 8254, that it can have the operating frequency of 10 megahertz also. Another feature of 8253 and 8254 programmable interval timer ICs are that in the 8254 we have a command which is known as read back command. So in 8253 and 8254 we were having the counters, and the counters, they are initialized with a count value, and this count value, when it becomes 0, then the counter, it has provided that specific time delay. Now if we want to read the count value at any time, then this read back command is useful. So in 8253 this feature is not available, that you cannot read the value of the count at any time. Only in 8254 we have this read back command. So this readback command, it allows the user to check the count value, the programmed mode that the timer is working in, which of the 6 modes, and the current mode and current status of the counter. So all these things can be checked by the user at any time using this readback command, and this feature is only available in the 8254 IC. So these were the features of the programmable interval timer ICs 8253 and 8254. So now let's come to the pin description and the block diagram of the programmable interval timer 8253. Here we will study about 8253 only. So coming to the pin diagram, we will have, this is the pin diagram of 8253. You can see that it's a 24 pin IC. We have 24 pins here. Out of these 24 pins, the 8 pins from 1 to 8, they are for the data bus. Data bus is the 8-bit data bus is here from D0 to D7. It is the bidirectional data bus. Then for each of the timer we have the 3 signals. 2 input signals, that is the clock and gate, and 1 output signal is out. So each timer, it is having 2 input signals, the clock and the gate, and 1 output signal out. So we have the 3 timers, timer 0, 1 and 2. So each timer will have the 3 signals, clock, which is denoted by CLK, then gate and out. So clock and gate are the input signals and out is the output signal of the timer. So we have for timer 0, we have clock 0, out 0, gate 0. For timer 1, we have clock 1, gate 1 and out 1. These are for the timer 1. And these 3 are for timer 2. This is for timer 0. So the 3 timers, they will have the 3 signals which are occupying the pins 9, 10, 11, 13, 14, 15 and 16, 17 and 18. Then we have the ground and the power supply pins. Okay, so power supply pin, it is at the 24, that is positive, and ground is connected at the 12th number pin. Then we have A1 and A0. These are the timer selection bits. Through these address lines A0 and A1, the 8253 it is going to decide that which of the register it has to select. Okay. Then we have chip select, read and write. This is write signal. This is read and this is chip select. So these are the 24 pins of the IC 8253, and these pins are descriptions, their names are written here. So let's study each of the pins one by one. First, we will see the block diagram because block diagram is also related to it. So this comes the block diagram of the 8253 or 8254 programmable interval timer. Here we have the data bus buffer which is connected to the data bus. This is our data bus bidirectional. It is an 8-bit bidirectional data bus. So we have D0 to D7, 8 bits represented here. And this data bus is buffer. It is connected to the internal bus. Okay, so that the data, if it is to be transferred to any of the counters, it can be transmitted through this, transferred through this internal bus. Then we have read-write logic. Through this read-write logic, we have the signals read, write, A0 and A1. They are connected. Then we have the chip select signal also connected towards it. The function of this read-write logic, it is to provide the control signals to all the other components of the 8253 IC. Then we have the control word register. Okay, so control word register, it has the control word which decides that in which mode the three counters are operating. Now in the counters, they have the two input signals, clock and gate, and one output signal out. For each of the timers, we have the three signals associated with it. And the counters, they are connected to the internal bus so that the data can be transferred easily between the various blocks. So this is the block diagram, and it is the pin diagram of the 8253 IC. Now let us study all the pins and all the blocks of the IC one by one. First, we will start with the block data bus buffer and the 8-bit bidirectional data bus. So our first is data bus and data bus buffer. So the data bus, it is the bidirectional 8-bit data bus, and the buffer is also a bidirectional 8-bit buffer. Okay. Now the use of this buffer is to interface the timer 8253 with the system data bus, because the programmable interval timer, it is connected to the microprocessor. It will perform the timing and counting operations for the microprocessor. So it will be connected to the data bus of the microprocessor through this data bus buffer. Okay, so the function is to interface the timer with the microprocessor data bus. Okay, now the operation of this buffer, data bus buffer, it is controlled by the chip select line. So the operation of this data bus buffer, it is controlled by the chip select line, and this chip select line, if it is low, because it's an active low signal, so when it is low, it means that it is telling that the microprocessor, it wants to communicate with the 8253 IC. So if this is the microprocessor and it is the IC 8253, so if the microprocessor wants to communicate with 8253, then it's going to send the chip select signal. It is going to activate, and this chip select signal, we have in between the data bus buffer is also there. So data bus buffer, it is going to transfer the data between the microprocessor and the 8253 if this chip select line, it is enabled. So the operation of this data bus buffer, it is controlled by the chip select line. If it is low, then only this buffer will act. If it is high, then this buffer, it will go into the high impedance state. So we can say that this data buffer, it is controlling the transmitting and the receiving of the data between 8253 and microprocessor. Now when the data, it is transmitted by the microprocessor by the in and the out instructions, these instructions are used to transfer a data byte or to receive a data byte from a peripheral device. Peripheral device are the input output devices. So when 8253, it is connected to microprocessor, it is acting as an input output device. So the microprocessor is going to use the in and out instructions for transmitting the data or receiving the data from the peripheral device or from the timer. So this data bus buffer, it is going to receive or transmit the data when microprocessor is executing the instructions in and out. So we can say that the data bus buffer, it has three basic functions. First function is programming the modes of 8253. Because the modes, they are decided by the control word, and control word is provided by the microprocessor. So microprocessor is going to write the control word or through the data bus buffer into the control register. So indirectly we can say that the data bus buffer, it is controlling the programming of the modes of 8253. Now the second function of this data bus buffer is that this data bus buffer, it is used to load the count value in the timers, and this count value, it is provided by the microprocessor. So the time period for which it wants the time delay, so that time delay, according to that time delay, it will calculate the count value, and that count value will be loaded by the microprocessor through the data bus buffer in the timers, timer 0, timer 1 and timer 2. Now third function is to reading the count value from the timers. The timers, because we have loaded the count in the timers, then the count timers, they are going to decrement the count, and it will decrement until the count reaches 0 value. So anytime if we want to read the count value from the timers, from the three timers, then we can read it through the data bus buffer. So data bus buffer, we can say that it is used to read and write the count value into the timers or from the timers, and also it is used to program the modes of 8253 through the control word, which is written in the control register. Now this data bus buffer, it is connected to the data bus of the microprocessor. So it is, we can say that data bus buffer is connected to D0 to D7 pins of the microprocessor. Okay. And the transfer of data, it is taking place through these pins D0 to D7. Now these pins D0 to D7, they are usually in the high impedance state. They are initially in high impedance state. Now when the chip select signal, it is enabled, means its value is 0, it means that microprocessor, it wants to communicate with the chip, and then these lines, these D0 to D7 pins, they get activated and the data is transferred. Now if the read signal is activated means its value is 0 because it's an active low signal, so it will be active when its value is 0. Or if the write signal it is active means its value is 0. Then if read is 0, then the count value will be read by the microprocessor, and if write signal it is activated, then the count is loaded into the timers. So we can say that the D0 to D7 pins, they are used according to the chip select signal and read and write signals, and then the data bus buffer will work. Okay, so data is transmitted through these pins D0 to D7 from the microprocessor to the timer 8253. Okay, now next block in the block diagram of 8253, it is the read and write control logic. You can see in the diagram here we have the read and write control logic, and in this logic we have the signals read, write, A0, A1, and it is also connected to the data bus buffer, and chip select signal is also there. Also this signal is connected to the control word register. So the function of this read write logic, it is to accept the data from the control bus and also from the address bus. From the address bus A0, A1, it is getting that which of the register, internal register it has to select, and then through this it also generates the control signals, and these control signals are given inside the IC. Okay, so the function of the read and write control logic is to accept input It accepts the input for the system control bus, and in turn it generates the control signals for the overall device operation. So you can see that here we have the read signal. So when it is activated, then the counters will be read. If write is activated, then the count will be loaded into the counters. A0 and A1, they will decide that which register it has to select, and this logic it will work only when this chip select signal is enabled, because if it is enabled, it means that 8253 and microprocessor, they want to communicate with each other. If it is disabled, means if its value is 1, then the chip will not be selected and the data bus buffer will be in the high impedance state and no transfer of data will takes place. So this read and write control logic, it is its function, it is decided by the chip select line. Okay, it is enabled. If it is enabled, then only this logic will work. If it is disabled, then no operation will occur because the chip is not selected. Okay, so the most important signal here, it is the chip select signal. So this chip select signal, it is used to enable the communication between the 8253 and the microprocessor through the data bus. Okay, so the data bytes, they are only be transmitted or received by the microprocessor only when the chip, this 8253 chip, it is selected through this chip select signal. And this chip select signal, it is an active low signal. So how this chip select signal, it is enabling the communication. When this chip select signal is low, it will enable the data bus buffer. And and the data bus buffer, because it is connected to the data bus of the microprocessor, so data will be transmitted or received through this. So what this chip select signal is doing, it is enabling the data bus buffer. If it is 0, then this data bus buffer will be enabled. If it is 1, then this buffer will be in the high impedance state. Now this chip select signal, it is decided by some circuitry. Because the address lines, the 8253, it is connected as a peripheral device to the microprocessor. So peripheral device, it will have an 8-bit address. Now for this 8-bit address, they are going to use the 8 address lines of the microprocessor, like A0 to A7. These are the address lines which will be used for addressing the 8253 chip. Now out of these 8 address lines, A0 and A1, they are connected to the read and write control logic, and rest of the lines, that is from A2 to A7, they are used to form the chip select signal, CS bar. So these address lines, how they are connected to form the chip select signal, the every microprocessor, they will have a different circuitry for it. So the configuration of the system employs the some type of circuitry to define the chip select signal. Now the next signals in the read and write control logic are the read and write signals. The read and write signals, they control the direction of data transfer between the 8253 and the microprocessor. So they are controlling the direction of data transfer on the 8-bit data bus. If read signal, because it's an active low signal, it is having a bar over it, so it will be active when its value is 0. So when this signal it is low, that means that the count value which is there on the 3 counters, counter 1, counter 0 and counter 2, so that count value will be read by the microprocessor. So the data, it is going to transfer from the counters or from the 8253 IC to the microprocessor. So when this is low, CPU is reading the data from the 8253 in the form of count value. Now comes the write signal. This signal is also an active low signal, so its value, it is active when its value is 0. Now when this signal is low, it means that the data which is available on the data bus, it will be written in the 3 counters or in the control register. So when it is low, the CPU is writing the data into the 8253 in the form of mode information, that is in the form of control word, because control word contains the information about which mode will be active. So mode information or loading the count values into the counters. So count value on the control word, it will be written by the CPU into the 8253 when this write signal is enabled. Now if these two signals, they are high, okay, means this is high and this is also high. Now, when these two signals are high, then the data bus buffer, which is enabling the data transfer, which is connected between the 8253 and CPU, it will go into the high impedance state. If the chip select signal it is enabled, it's 0, means the chip is selected, but the read and write signals, they are high. So the data bus buffer, it will go into the high impedance state and no transfer of data will take place between the 8253 and the microprocessor. So this is the function of the read and write signals. The two other signals which are connected to the read and write logic were A0 and A1. These are the two input lines which will decide that the microprocessor, it will write or read the data from which of the timers and which the control register. So which of the internal register will be connected, that will be decided by A0 and A1. So these two input lines, they allow the microprocessor to specify that which of the internal register, means either the control register, timer 0, timer 1 and timer 2, which of these register is going to be used for the data transfer. So now let's see the table for it, that how the two lines, they are deciding the transfer of data. So we will see that the A1 and A0 lines and the CS bar, chip select, read and write, all how all these signals, they are deciding that which operation is going to be performed by the 8253. So when this chip select signal it is 0, then only 8253 will communicate with the microprocessor. Now when this read signal is 1 and write signal is 0, means this is activated, this is not activated, because these two signals are active low signals, so they will work only when their value is 0. So write operation will takes place. Now if the value of A1 and A0 it is 0, then counter 0 is selected, and here write signal is activated, so operation will be to load the count value into the counter 0. So this A1 and A0, they are 0, so counter 0 will be selected, and here the write signal it is 0, it's active, so it will be a write operation. So the operation will be to write the count value into the counter 0. So this will be the operation when the value of A1 and A0 is 0 and write signal is activated. Now we have again chip select signal is 0, read is 1, write is 0, and A1 and A0 they are 0, 1. Then the counter 1 will be selected, and again it will be a write operation. So the function will be to load counter 1. Then we have all the signals will be same. Here if we have 1 0, then counter 2 will be selected. So the operation will be to load the counter 2. Then we have the chip select signal is 0, read signal is again 1, this write is 0, and here if we have 1 1, then the operation will be, because the control register is selected, so here the operation will be to write the mode word, that is to write the control word into the control register. So 0 0, it is basically selecting the counter 0. If this is the value of A1 and A0. If it is 0 1, then 1 first counter is selected. If it is 1 0, then second counter is selected, and if it is 1 1, then control register is selected. Now these four operations, these are the write operations, because write signal is activated here. Now if read signal is activated, then the selection will be based on A1 and A0, and then read operation will be performed. So here we will have 0, read will be activated, write will be 1, then 0 0. So the counter 0 is selected, so counter 0 will be read. So read the timer 0. Then we have 0 0 1. If it is 0 1, then counter 1 is selected, so it will read the timer 1. Then again chip select signal 0, read signal is 0, write is 1, it is 1 0, then it will read the timer 2. Now if it is 1 1, then control register will not be read, because for the control register no read operation is associated with it. So 1 1 will have no function, no operation will be there. Then if the value of this CS is 0, read signal is 0, 1 is 1, and then it is 1 1. Okay, so we can say that no operation is performed, and the data bus buffer will be in the impedance state. Okay, now next, if the chip select signal is 1, it means that the chip 8253 is not selected, and whatever will be the value of this read, write, A1, A0, the chip is not selected, so we can say that the operation is that the chip is disabled, and the buffer it is in the high impedance state, because chip select signal is 1, so chip is not selected here. Now if the chip select signal is 0 and the read and write signals, they are at logic 1, but because their value has to be 0 for the read and write operation, and if their value is 1 1, and whatever will be the value of A1 and A0, again no operation will be performed, and again the buffer will be in the high impedance state. Okay, because these signals has to be low, any one of the signal has to be low to perform the read and write operation. So these in the these four operations, they are the write operations, because write signal is activated, and these three are the read operations, because read signal is activated. Okay, so this is the table which is showing that which internal register is selected according to the value of A1 and the A0. Now these A1 and A0, these are basically the address lines of the microprocessor. So the 8 address lines are deciding the address of the 8253 IC. So out of the 8 address lines, 2 are deciding that which internal register is connected, and the rest of the lines, they are deciding the chip select signals. Now next come the control word register. So the control word register, it is used to program the timers in different modes. As we know that the 8253, it has 6 modes. So any of the timers can be programmed in any of the 6 modes. So these modes are decided by the control word registers, and the modes control the operations of the 3 timers. Now this control word register, it is selected when the A0 and A1 lines, they are at logic 1. We have seen in the table that control register is selected when A0 and A1 at our logic 1. Now when the read signal is activated and this control register is selected, then because control register, it has no read operation associated with it, so we cannot read the control register. So when this read signal is low, no read operation is performed for control register. We cannot read the control word, so this will have no effect on it. Now if the value of the write signal, it is 0, means it's low, then the control word which is provided by the microprocessor, it will be written into the control register. Now this control word, it is an 8-bit word, because the data bus of the microprocessor, it is 8-bit data bus, so 8-bit data is going to be written. So control word, it will be an 8-bit word, and it will be written into the control register. So control register will be an 8-bit register. Okay, and this 8-bit word, it is going to decide that the timers will work in which of the modes. Okay. Now when this write signal is activated and control word has been written into the control register, so the counters will be loaded with their count value, which is also provided by the data bus buffer. So the next we have the counters, the 3 counters which are present in the 8253 IC. Now 8253, it has 3 16-bit counters. And each counter has 3 signals with it. And these 3 signals are, first is clock, second is gate, and third is out. Clock and gate are the input signals and out is the output signal. So we can say that the counter will have 2 input signals and 1 output signal. First we will study the clock signal. So the clock input pin, it provides the 16-bit timer with a signal which decides that the timer, it is going to decrement. Means it starts the decrement process of the timer. So when this clock signal will be given to the timer, it is already loaded with the count. So it will start decrementing the count until its value reaches to 0. Now these counters, these 16-bit counters, as they are the down counters, so they are always going to decrement the count. Okay, and also these counters, they decrement the value of the count from every high to low transition of the clock input. Means that if this is the clock signal, then high to low transition means this is high and this is low. This is again high and this is again low. So from every high to low transition, the counter is going to decrement. Suppose the counter, it is initialized by a value of 5. So when the transition takes place from high to low of the clock input, then the counter will be decrement. So its value will become 4. Again we have the high to low transition, so again the counter is going to decrement, so its value will become 3, and it will decrement in such way that the last value 0 comes. Okay, so for every high to low transition of the clock input, the counter, it is going to decrement the count value. So this was the clock input. Now comes the gate. So gate signal, it is used to initiate or enable the counting process. Means the counting process or decrementing process, it's going to be start when the gate signal will be given. Okay, and the effect of the gate signal, it depends on which of the 6 modes of operation is being chosen for the timers. So the timers, they are going to start the decrementing process only when the gate signal is given to it, and the clock input, it is every time the clock pulse, it is transiting from high to low, then the counter will be decremented. Then we have the output signal. So this signal, it provides an output from the timer, that if we want to read the count value at any instant, then we can read the count value from the output signal. Okay, and at any time we can also read the counter, and at the last when the counter has become 0, then also it will provide us the output of the timer. So these 3 signals, the clock input, gate and output, they are associated with each of the timers, timer 0, timer 1 and timer 2. So the output of the timer, this out function, it provides an output from the timer, and its function, its function basically depends upon the mode of operation in which the timer is being programmed. So we can say that its function, so in 8253 we have the 3 16-bit counters, which are the down counters. That means they are initialized with the count, and then they decrement the count until its value becomes 0. Now to understand the functioning, that how the timers they work, let us see the internal structure of the timers. So the internal structure of the timer, it consists of three elements: input element and counting element and output element. The function of the input element is to get the count which is loaded by the central processing unit of the microprocessor. The microprocessor, it is going to provide the count through the data bus buffer, and that count will be loaded into the input element of the timer. Now once the input element has been initialized, it will become, the count will remain there until it is reloaded with a new count. So if you have initialized the count, like suppose you have given the count value of 10, so 10 will remain in the input element until it is reloaded, the timer it is reloaded by some other count. Okay, so input element, it is going to contain the count 10 in it. If we have given the count value 10, then 10 will be loaded into the input element. Now this input element, it will provide this count to the counting element, and this counting element will start decrementing the count when it will be given this clock and the gate input. As we know that the timers, they are the down counters, so it is going to decrement the count, and it is going to decrement the count for every high to low transition of the clock input. Because if see, this is the clock pulse, so for every high to low transition, the counter is going to be decremented. So suppose the counter, we have loaded it with 10, so for this it will become 9, for this it will become 7, and for this high to low transition it will become 7. So when the clock pulse is given, the counting element will start decrementing the count. Now this counting of the decrementing of the count, it is available at the output element. Because this output element, it is basically a transparent latch, and the function of this latch is to, whatever is the output, whatever will be the input, the output will be the same. Suppose like for first clock transition, high to low transition, the count has been decremented and its value has become 9. So the output element will give the output here as 9. Okay, so what this output element is giving, it is providing the current value of the count at the its output. Okay, now suppose that if we want to latch the output of the counter, like if we want that this 9 value is latched, so this 9 will remain at the output, and the counter, it will continue its decrementing of the counter. So 9 will be there, then 8, then 7. So in this way, the counting element, it will continue decrementing the counter, but at the output we are getting the latched output, which is 9. Okay, and the microprocessor can at any time, it can read the value of the count from this output element. Now once the microprocessor has read the output from this output element, then this output element, it will again be updated, and it is going to again show the value of the count which is currently this counting element is counting. So once this 9 has been read by the microprocessor, then again this output element will be updated, and the suppose the current value of the count is 7, so it will again start showing the value of the counter. So in this way, the timers, they work having these three input elements. So let us write the function of each of the element. Input element, so we can say that the function of the input element is that the count value in it is loaded into the input element, and it remains in this element until it is reloaded with another count value. Next, we have the counting element. So this count value which is loaded into the input element, it is transferred to the counting element at an appropriate clock input. You can see in the diagram that to the counting element, the clock input and the gate input, they are connected. So at an appropriate clock input, this low count which is loaded into the input element, it is transferred to the counting element, and once the count has been transferred into the counting element, the down counting, that is decrementing the count, it starts. Now this value of the count, current value of the count, it is available at the output element. So in the diagram, we can see that the output of the counting element, it is connected to the input of the output element. So the current value of the count, okay, here I have written that the current value of the count at any moment, it is available at the input of the output element. So whatever will be the current value of count in the counting element, it is available at the input of this output element. Now output element, I have said that it's a latch and it's a transparent latch. So whatever will be its input, that input will be available at its output. Okay. So it is acting as a latch here, transparent latch. So the current value, because at the input of output element, we have the current value of the count. So that current value of count, it is available at the output of this output element. So the third element is the output element. Okay, so it's a transparent latch, and the output of the latch, it follows the input. And input is what? It is the current count value. Now the output of the value of this count, it can be latched by using appropriate mode, because we know that there are different modes in which the 8253 timers, they can be programmed. So depending upon the modes of operation, the output of the count, means the value of this count, can be latched. So the value of the count, it can be latched by issuing appropriate control word in the control register. And once the output value of the counter, it is latched, the internal counting continues. Means suppose that the current value of the count, suppose it is 9. So when we are latching this, if we are latching the output of the counter, then the output of the output element will become 9, but the internal decrementing of the count will continue. Okay. And then this count, this microprocessor, it is always going to read the output of this output element. Okay. So microprocessor always read the output of the output element. Now, once it has read the this output element, then the output element again becomes transparent, and whatever will be the current value of the input, that will be available at the output. So once this 9 has been read by the microprocessor, the output element, it will again become a transparent latch, and this 7, 6, 5, 4, 3, 2, that means the current decrementing of the counter will be available at the output element. So this is how the timers they work. So in this video of 8253 and 8254 programmable interval timer, we studied about these ICs, their basic features, and then we studied the block diagram and the pin diagram. And then one by one we studied the description of all the blocks of 8253 and the description of all the pins of 8253. So I hope that this topic is clear to you. Thank you.